Hi everybody, Professor Chance here with something to think about. Today we're going to have a little bit of fun, I know I am, because we're going to talk about a topic that I really love, and that is the pseudo-science of superheroes. Now I love superheroes, I've always have, and today we're going to look at someone particularly special, but wait a minute, I believe that I'm a little bit improperly dressed for this. That's better. We'll be right back. All right, welcome back to Something to Think About. Today we're going to talk about the pseudo-science of superheroes. And we're going to focus today on my favorite and the biggest and the baddest of all superheroes. That's right, Superman, the Man of Steel. Now, Superman goes all the way back to 1938 as being the first incarnation of this character. And as you probably know, he was born on the planet Krypton. Krypton exploded, and Superman's parents, Jor-el and Lara, in their infinite wisdom, I guess, shot him out into the infinite void of space in this little spaceship just before the planet blew up. And luckily for him, he landed on Earth and was discovered by the kindly couple of Jonathan Martha Kent, who named him Clark. So that's where you get Clark Kent, who is Superman. Now, this is Christopher Reeve, the actor who portrayed him in Superman the movie in 1977. Me and my formative years at that time, this is the guy, this is the hero, this is the true embodiment of Superman, the Man of Steel. There's been many incarnations of Superman going all the way back to the 50s and going forward even till today. And these are just live action, either television or movie incarnations of Superman. There's been several animated features and radio features and many, many other types. But this is Superman. And right now, Henry Cavill has the honor of wearing the suit in the movies. So, what are the characteristics of Superman besides him being heroic, true embodiment of a hero, sacrifice, justice, believes in using his power to do good, not to lord over, not to control, but to do good, try to make the world better, and actually bring hope. Of course, in the movie, this is supposed to mean hope, although, you know, word to the wise, I think that's an S. But don't tell anybody. All right, so what is it about him? Now, in most designations, he's been listed as 6'4", 225 pounds. Just so happens those are just about my measurements. But beyond that, he's got the power, strength, super strength, flight, speed. He's invulnerable to almost any harm. I learned that word invulnerable by reading comic books. So there is some knowledge that you can gain by reading these things. And just by the way, I have thousands and thousands of comic books, mostly Superman, mostly Justice League, a little bit of Batman, a little bit of Spider-Man. It goes all the way back to the 80s. But I love reading them. I'm not a collector. I like to read them. So, but as I said, he's heroic, sacrificing, hopeful. He has great leadership. He leads the Justice League, created by Jerry Siegel and Joel Shuster in 1938. Action Comics #1. All right, so let's talk about his powers. Now, Superman has been given a vast array of powers since at the beginning. In the very early stages, he could just jump very high and was pretty strong and bulletproof. But now he's got a vast array of powers. We're going to go off of the ones that he's most well known for and the ones that, you know, are shown in the movies right now. So let's go into some of those powers. First of all, very fast, super speed. He can move very quickly, rivals the speed of even the Flash, for some of you who knows that. Can move nearly the speed of light, if not beyond that in certain circumstances. All right. He has heat vision. He's able to emit enormous amounts of heat from his eyes and burn things, ignite things, warm things. He can even warm a cup of coffee, and he's been known to have heat in excess of nova intensity, which is extremely hot. He's also got freeze breath, so he can go on the other side. He, as you can see in this video, he's able to freeze this entire lake by breathing on it, and then in this movie, he then lifts that up and uses it to douse a chemical fire in a refinery in the movie, which was probably the best thing about Superman 3 if you saw that movie. The rest of it, not so much. But he also, and this is probably one of the things he's most known for, and that's his super strength. Superman's strength is probably uncatalogued. We're going to give a little attempt to try to explain some of this in a second, but this is one of his great hallmarks, his incredible strength. And I think the thing that makes him the most coveted as a hero is his ability to fly. That was always the wonder. I remember even in the movie for 1977, as you can see him flying around here, but in that movie, they build it as you will believe a man can fly. They went a great deal into making that believable in that movie, and they've continued to do that ever since. Maybe not some of the TV shows, but certainly in the movies. Okay, so where does his power originate? Now, most in the comic book world say that it is a combination of the radiation, the solar radiation, and Earth's lighter gravity. So we're going to take a look at those particular things. Now, here's a video of astronaut on the moon bouncing around. The moon, as you know, is smaller and thus has a weaker gravitational pull than the Earth. So the astronaut can jump, and the pack on his back, which on Earth would weigh about 400 pounds, only weighs about 100 to him. All right, so Krypton is a much bigger planet than Earth. Some say, and I looked around in different, catalogs of Superman lore, and most say that Krypton is about the size of Jupiter. Now, of those of you who know about this stuff, Jupiter is a gas giant, and it's not as dense as the Earth, but is much, much bigger, almost 10 times bigger. So here you see we calculate, starting with the force of gravity, and you'll recognize these equations based upon gravitational pull of two bodies and their distance. Now, if you make those equal to each other, then you can find out the force of gravity on Earth versus the force of gravity on Krypton if it had the same mass but much larger size. So now if you take the volume, which is 4/3 pi times the radius cubed, and calculate the density of any planet, that's the mass of that planet divided by its volume, you can calculate the density of Earth and apply that density to Krypton, after you go through all of this, you'll find out that the force on Krypton is 10 times that force on Earth. A guy weighing 200 pounds on Earth would weigh then 2,000 pounds on Krypton. And so 10 times the strength. So that can give you an idea of what it would take in order for Superman to thrive on Earth based upon this enormous gravity that's on Krypton. Now, I like to use energy where possible in order to do calculations and to figure out what's going on. And guess what? We can actually use Einstein's famous relationship, but this is a mass energy equivalence. And basically saying that energy is equal to mass times the speed of light squared. That tells you a lot, and you can use this in a lot of different ways. So now, let's look at Superman and the energy output it would take to do some of the feats. Now, the strength feat I showed you showed him lifting the part of the San Andreas fault and repositioning it so that you could stop the earthquakes. Well, let's just suppose that the mass of that fault piece was 1 times 10 to the 12th kilograms. And on the surface of the Earth, gravity is, the acceleration of gravity is 9.81 meters per second squared, or let's just say 10. And let's say that he lifted this a height of 100 meters to put it back into its place. Now, so work is calculated as, and this is a potential energy really, and that is the mass times the gravity times the height. And you can see that that gets you about 1 times 10 to the 15th joules. Now to put that into perspective, a megaton of explosive energy is equal to 4.18 times 10 to the 15th joules. So it took Superman about 1/4 of a megaton to lift that plate up to 100 meters. Pretty impressive, pretty impressive. So let's take a look at the energy density capabilities within different substances that we're familiar with. Wood, as you can see, has about 16 megajoules per kilogram. So you get that much wood together, that's how much energy you can get. And as you can see, you go down the list, natural gas has a pretty high one, relatively speaking, 55 megajoules per kilogram of natural gas. But look at uranium-235, 3.9 million megajoules per kilogram. That's quite a bit. Okay, well, keep that in mind. Now, one of the greatest feats that Superman has been on record of doing, and not back in the the Silver Age when he's juggling planets and doing all kinds of crazy stuff, but he's been known to move the Earth. So let's just say we have the Earth's mass at 5.97 times 10 to the 24th kilograms. And the sun's mass is 1.98 times 10 to the 30th kilograms, because we're calculating the force that the sun has on the Earth as it orbits at a distance at this point of 1.5 times 10 to the 11th meters. You run that through, same equations as before, and get 3.5 times 10 to the 22nd newtons of force. Now, let's say that Superman moved it a meter, and here he says a few more inches, but if he moved it a meter, then the energy is a force times the distance, and so Superman was able to exert or required, I should say, 3.5 times 10 to the 22nd joules of energy, which is equivalent to 8.4 million megatons. Now, another thing, think about is, okay, where is he storing all that energy? Because let's say his mass, which if you saw his weight and height, wasn't much more than a regular guy, 102 kilograms. So his energy density is 3.5 times 10 to the 20th joules per kilogram, which is 90 million times of that in uranium-235. And let me just say that this is not the limit of his power. So he's packing a lot of energy, he's packing a lot of power, and he can dish it out when he needs to. Just so you know, this is a little interesting side note. When you are actually conducting nuclear fission within uranium-235, what you do is you introduce a neutron. This becomes uranium-236 for a second, but it splits into two isotopes and two more neutrons, which continues to do the same thing. Those isotopes, one is barium and the other is krypton. Interesting. All right, so what about flight? And this is the other interesting part of this. Now, I drew all these, equations and all this. This is subject to Alcubierre's warp drive. This also, NASA has a gentleman, Sonny White, who's been working on this. But the whole idea is about moving a spaceship through space by warping space-time. And I talked about this in a prior show, where you could squeeze space-time in front of you and expand it behind you and move through at incredible speeds. Now, the problem is that an enormous amount of energy, at least what's been calculated to date, is required to do anything like this. But the equations say that it's possible. But the energy equivalent right now would be equivalent to the mass of Jupiter, utilizing that energy and mass equivalence relationship I just showed you. And you require exotic matter. Now, you could achieve speeds well in excess the speed of light. And these wouldn't really be speeds. You would just be bending and folding space-time and moving your vessel to another location by doing that. So you're really not violating the speed of light rule in the universe. You're just bending space-time, which the equation says. Now, since Superman is able to harness and store these incredible energies, perhaps this is the method by which he propels himself. So, what are we saying about Superman? So his entire body is a solar battery, and he continuously charges himself and brings energy in from the sun and converts it into the different various powers that he has. Now, perhaps he's got some sort of organ in here that transfers or transforms that power into these different abilities that he has. But he does deplete his sources, and that's been shown as he exerts himself, and not able to recharge fast enough, he can deplete his energies, and it's been done before. He has incredible molecular density, and this gravity and solar evolution. Now, the reason I say evolution, because it's been shown that his body does change. He gets more powerful over time as he's continuously exposed to the sun. So he evolves. He controls his powers even down to the microscopic level. And just simply that he doesn't crush people anytime he touches them. But he also has things like microscopic vision and things like that. Speed and strength are perhaps due to his gravity warping ability. Now, one thing I haven't talked about is kryptonite. And kryptonite is his only weakness that we know of. And it degrades Kryptonian cells and depletes the energy reserves. And long enough exposure to kryptonite will kill him. So, not to leave this in a bummer, but, and here's some of the sources I've used, and I'll put these into the, down in the comments, and of course, like and subscribe and all that, but take a look at the comments and you'll see some of the sources I used. But the Man of Steel, yes, this is my guy, favorite hero. Now, next time we'll do some other heroes, some different types of powers, and we'll talk about that. But I hope that this is giving you something interesting to think about. And I know before you all jump on me on my equations and my physics and the origins and his powers and all that, just put it in the comments. I will address it and we'll fight about it. But it's fun because we're living in an age where superheroes and the movies is a hot thing. So let's enjoy it. Okay? All right. This has been Chance Glenn. Let's keep on thinking. And up, up, and away. Psych. Oh, hi everybody, this is Chance Glenn. Thank you for watching the show. I hope I've given you something to think about. I want you to continue to support us and follow us. First of all, you probably see this show on YouTube, so be ready to follow it and keep up with every post that we make. We're also up on Facebook under Something to Think About. Our webpage is under the Morning Bird Foundation at morningbirdfoundation.org, and you should be able to find the show there. Also, you can email us, you can post on Facebook, got a Twitter account as well. So you can communicate with us. I'll be periodically answering questions from you, so look out for that. But continue to just help us out. You can like and subscribe. That goes a long way to doing that. But most of all, we want you to keep thinking. We want you to give you something to think about. Take care.